Okay, section 4.3, quick graphs using intercepts. And so, chapter 4 is all about graphing, and you guys got a taste of it with the last lesson. Last lesson we focused on using T-charts, which is always a good backup. Sometimes it takes a little bit longer. Tonight we're not going to spend as much time, so we're going to learn how to graph a little bit more quickly. And I want to begin by posing a question. And the question is this: what's the smallest number of points you would need to construct a single line that goes through all of those points? I want you to think about that for a second. What's the smallest number of points that you would need to be able to construct a line that would go through all of those points? If you think about your homework from the last section, when we were using T-charts, sometimes we had 4, 5, 6, maybe even 7 points, and hopefully they all lined up and you could draw a straight line through all of them. If you said 1, 1 would be incorrect, but I kind of want to look at why. So imagine you have one singular point. Okay, you can definitely construct a line that goes through this point, but the problem is you can construct multiple lines that go through this point. You can construct an infinite number of lines, really, that would travel through that point. And we're looking for one single line only. So what about 2 points? Well, let's take a look at 2 points. With 2 points, how many lines could go through these points? And this is something you'll talk about in geometry next year. And the answer is only 1. So to construct one single line, it has to be governed by at least 2 points. Of course, there are going to be other points on that line. You could have, many, many more, but the smallest number of points you need to construct one single line is going to be 2. And so instead of involving a T-chart tonight with several points, we're really just going to be focusing on 2 points only. Okay, so you'll be constructing lines with 2 points. Okay. Let's go ahead and get into it. Another way to graph equations is to find the intercepts of the equation. And you might have guessed it, the 2 points you're going to be focusing on are called the x-intercept and the y-intercept. Okay, and I've given you definitions of both of those here. If you want to go ahead and read them to yourself, feel free. But I need to make sure that everyone understands the difference between an x-intercept and a y-intercept. And let's focus on the x-intercept first. So it says the x-intercept is the point on the graph where the graph crosses the x-axis. Since the graph intercepts the x-axis at this point, the y-coordinate of an x-intercept is always 0. And that might take a little while to digest. I'm going to draw a little graphic for you to maybe help you out. One of the things that we need to make sure everyone's clear on is the difference between the graph and the coordinate plane. So I'm going to color code these. Okay. In black, we have the coordinate plane. Please don't call that the graph. Okay. The x-axis and y-axis both represented here in black. That's what we call the coordinate plane. The red line is the graph. Okay, so let's go back and read that. The x-intercept is the point on the graph where the graph crosses the x-axis. So let's follow along the red line until it hits the x-axis. And it hits the x-axis right here. So that point where the x-axis is crossed over by the red graph, okay, that is what we call the x-intercept. Okay, and I want to point out that even though there are no hash marks on this coordinate plane that I have constructed, you might be able to determine something about the coordinates of this x-intercept. We're not going to know both numbers, but which number would you know? Well, if you imagine starting at the origin, right, and then traveling out, to your left to get to that point on the x-axis, we don't know how far we travel. Maybe we're traveling like -1, -2, -5. It's hard to tell. We don't have any hash marks. But what we do know is that we don't move up, okay, nor do we move down. We stay right on the x-axis. And when we stay on the x-axis, that means that the y value is 0. So the coordinates for this guy would be something, comma, 0. And for any x-intercept, the y coordinate is always 0. And so that's what this part up here means. The y coordinate, always 0. So just know that. It's kind of counterintuitive. For an x-intercept, the y coordinate is always 0. All right, let's take a look at y-intercept. It says y-intercept is the point on the graph where the graph crosses the y-axis. Since the graph intercepts the y-axis at this point, the x-coordinate of a y-intercept is always 0. Let's take a look at that. So just like last time, I'm going to construct another quick coordinate plane, nothing fancy. Notice that the coordinate plane here is going to be in black. And once again, I will do the graph in red. And see if you can locate with your eyes where the y-intercept would be. Remember, the y-intercept is where the red graph crosses over the y-axis. So it's right here, okay, right where the y-axis and the graph meet. Okay, so we would call that the y-intercept, and sometimes we just abbreviate this y-int, and that's fine. You can do that abbreviation. Let's see what we know about the coordinates of this guy. Notice for the x-axis, at the starting from the origin, we don't move right, okay, and we don't move left. We just kind of sit still, and when you sit still, that's a 0. So the x-coordinate here is 0, and then we move up. We move up like 2, 3, 4. I don't have any hash marks, so I can't tell. So it's going to be 0, comma something. Okay, so for a y-intercept, the x-coordinate is always 0. And we're going to use that knowledge to actually be able to figure out what the x-intercept and what the y-intercepts are. Okay, so make sure you understand the difference there. Here's another quick graphic. This time the x-intercept and y-intercept have been labeled on the graph. They've both been labeled. So if you look at the black line here, the graph, it's a descending line. Notice that the y-intercept crosses the y-axis right here, and the x-intercept crosses the x-axis right there. And most lines are going to cross over the x-axis and y-axis. The majority of lines are going to cross both. There are a few exceptions to that rule. Feel free to kind of think about that on your own. Okay, so now let's get into the process of actually graphing using our knowledge of intercepts. And here's where you need to pull out you might as well go ahead and pull out your graph paper. Okay, it says to find the x-intercept, just plug 0 in for all the y values of the equation. So we're going to begin by working with finding x-intercepts. We're going to find the x-intercept of this equation. Eventually we're going to find the y-intercept. We're going to take those 2 points and we're going to draw a line. So we're going to begin with the x-intercept here. Now why is it telling us to plug in 0 for all the y values? Well, we said back in the graphic just before, for an x-intercept the y value will always be 0. So I know before I even get started, okay, before I even get started, if I'm going to make an ordered pair for an x-intercept, it's going to be something, comma, 0. That y value is always constant for an x-intercept. So I'm going to take that 0 and I'm actually going to plug it in here for y. That's kind of the philosophy of what we're doing. To find an x-intercept, plug in 0 for y. And that's something you're going to have to memorize. Okay? All right, let's go ahead and do that algebraically. And we can go through this process together. So on your paper, what you want to do right now is just write down 4x plus 3y equals 12. That's our equation. While you're writing that, I'll point out that this is written in what's called standard form. ax plus by equals c. We'll be talking about different forms of the equation in the future, in the near future. A lot of different forms. You have slope-intercept form, point-slope form. Standard form is when both variables are on the same side. typically, and they're set equal to a constant number. And so using intercepts is a really good tool for standard form. All right, let's hop into this. All right, so we're going to plug in 0 for y. That's going to look like this. 4x plus 3 times 0 equals 12. Nice thing about this is, what is 3 times 0? Well, anything times 0 is 0. So 3 times 0 is 0. That cancels itself out. And we're just left with 4x equals 12. Divide by 4 on both sides, and we're going to figure out what the x value is. Okay, so here it looks like the x value is 3. So we would say that 3 is the x-intercept. I knew that the 0 part was, there for the y. Now I know that the 3 is there for the x. So to fill in the blanks down here, the x-intercept is 3. Okay, and the line crosses the x-axis at the point 3, 0. So just kind of file that away. We know that the x-intercept is 3. All right, now let's do the same thing, but let's find a y-intercept. Okay, so to find the y-intercept, we're going to plug in 0 for all of the x values. Okay, so just like we talked about last time, if I'm trying to imagine what these coordinates are eventually going to look like, okay, for a y-intercept, the x is going to be a 0, so it's going to be 0, something. I just need to figure out what that something is. Since x is always 0, I can plug in a 0 here for x. So to find the y-intercept, plug in 0 for x. So go ahead and copy this down as well on your paper. 4x plus 3y equals 12. And let's practice plugging in 0 for x. 4 times 0 plus 3y equals 12. Same deal as last time. 4 times 0 is 0. That's what's so easy about this. You kind of cancel out one of your variables by plugging in a 0 for it. And you're left with 3y equals 12. Divide by 3. And it looks like that y value is going to be 4. So we say that my y-intercept is 4. That would be the point 0, 4. And I can just fill in the blanks down here. Y-intercept is 4. And it's going to cross the y-axis at 0, 4. Okay, so notice we kind of did two different things there. We found an x-intercept, we found a y-intercept. And what we really did is we found 2 points. So we're going to take this information, and now we're going to make a graph. Okay, so go ahead and set up a coordinate plane on your graph paper. It can just be a very, very quick coordinate plane. Just x-axis, y-axis is fine. Okay, and we just want to remind ourselves, let's take inventory of what we already know. Okay, this was done on a previous slide, but you can just write down that the x-intercept, you can abbreviate that, no big deal. The x-intercept was 3. And the y-intercept was 4. It's as easy as going to your x-axis and putting a point at 3. And if you want to go ahead and it's always nice to label those, in my opinion. So that's our x-intercept. It's the point 3, 0. And then the y-intercept is at 4. And it's the point 0, 4. Notice the locations of the zeros in each one. You've always kind of known this, that whenever you're on the x-axis or y-axis, one of those values is a 0. You just need to know that it's kind of counterintuitive. For the y-intercept, x will be 0. For the x-intercept, y will be 0. Okay. All right, now what can you do? You can construct a line. You've got 2 points. 2 points is all you need. So you just need to construct a straight line through both points. And that's the point of what we're doing. Being able to draw that line really quickly. Obviously, I took a long time explaining this first one, but that's the basic idea. Find your x-intercept, find your y-intercept. You got 2 points. 2 points makes a line. Boom, you're done. It's actually a lot quicker than using a t-chart. Okay, So there you go. You've got your x-intercept, you've got your y-intercept, you've got a line. Is this line going up or down? It's going down. Is it steep or gradual? It's steep, and that's going to show up in the next lesson that we do. Okay, let's go ahead and do some independent practice. So on your graph paper now, I'm going to give you a couple of these to try on your own. So if you want to go ahead and set up a coordinate plane, I'll do this along with you. This is going to be example 2. Okay, so for your homework tomorrow, I'll expect to see a total of 3 examples. You just did the first one. This one is going to be example 2. Go ahead and make a quick coordinate plane. I'll kind of do it along with you. There will be times when I'll want you to have a more complex coordinate plane with hash marks and stuff like this. But as long as you're using graph paper right now, it's really not necessary for our current use. Just an x-axis and y-axis will suffice. Okay, and here's what I want you to do. I want you to graph the following equation. So let's graph -1/2 x plus 3y equals 3. Okay, so you want to go ahead and write that down on your graph paper. And the goal here is to find the x-intercept and the y-intercept. And remember, we're going to find an x-intercept by plugging in 0 for y. We're going to find a y-intercept by plugging in 0 for x. And I want you to go ahead and do that on your own now. So go ahead and find your intercepts. Go ahead and plot your points and make your graph. I want you to do this ahead of me. Hit pause now, and then we can reconvene to go over answers. All right, let's see what you came up with for your x-intercept. For the x-intercept, you're going to be plugging in 0 for y. And so I'm going to do that work right here below. So for my x-intercept, I'm going to write -1/2 x plus 3y, but instead of the y, I'm going to plug in a 0. Okay, so I'm working for my x-intercept here. 3 times 0 is 0, so that kind of cancels itself out. And I'm left with -1/2 x equals 3. And this is why we did solving basic equations earlier. You have to remember how to get that x by itself. If it's glued by -1/2, we're going to multiply by the reciprocal here. Okay, so take that -1/2, multiply it by -2/1, or -2, however you like to think about it. And that's going to cancel out your fractions. Okay, so once you've done that, you'll be left with x equals -6. That is my x-intercept, and I'll come up here and I'll go ahead and write that in. I want to file that information away. It's going to help me when I go to graph it. All right, for the y-intercept, I'm going to plug in 0 for x. So instead of writing -1/2 x, I'm going to write -1/2 times 0, okay, plus 3y equals 3. -1/2 times 0 is 0, and I'm left with 3y equals 3. Pretty easy math. Divide by 3, divide by 3, y equals 1. So it looks like my y-intercept is 1. Okay, now one of the things I will be testing you on is, can you convert these into the ordered pairs? For an x-intercept, right, the y value is always 0, so this would be -6, 0. For a y-intercept, the x value is always 0, so this would be 0, 1. And you can't get those reversed, because if you mess that up, you're not going to plot your points correctly. All right, let's see what we have for a graph. So -6 on the x-axis is over here, 2, 3, 4, 5, 6. So that's your x-intercept. And then 1 on the y-axis. So that's your y-intercept. And then I can connect them with a straight line. Now, the line that you created, it should look like mine, okay, because graph paper is pretty consistent. Is this line going up or is it going down? Hopefully you said that it's going up. Would you consider this steep or gradual? I would go with gradual on this one. Okay, so hopefully you have a match. I'm going to give you one more to do on your own. So go ahead and let's move on to example 3. And you will have to recreate your coordinate plane. So go ahead and write example 3. Make a new coordinate plane. I always want you to use separate coordinate planes here unless I tell you otherwise. Don't throw everything on the same coordinate plane. It's too confusing and it won't count when you turn it in. Okay, here's what I want you to graph. Let's try something with a little bit bigger numbers. So 18x minus 24y equals 72. And go ahead and do that on your own. Just like last time, the goal here is you want to be able to get your x-intercept and your y-intercept by plugging in those zeros appropriately. Okay, so go ahead and if you didn't get the last one by yourself, you should be able to do it by yourself now. Go ahead and find your x-intercept, your y-intercept, plot your points, connect them to make your linear graph, and hopefully ours match up. Go ahead and hit pause now, and then unpause when you're ready to reconvene. Okay, let's start with that x-intercept. Going to be plugging in 0 for y. So 18x minus 24y, instead of the y I plug in a 0, equals 72. 24 times 0 is 0, so 18x minus 0 is just 18x. 18x equals 72, divide by 18. And hopefully that's mental math for you. 72 divided by 18. You know, you can always check it in the calculator. That should be 4 for x. So my x-intercept is 4. And if I had to express that as an ordered pair, that's going to be 4, 0. Okay. Let's go for the y-intercept. For the y-intercept, remember I'm plugging in a 0 for x. So it's going to be 18x, plug in 0 for x, minus 24y. Watch that minus sign there. It's going to come along for the ride. Equals 72. 18 times 0 is 0. That's a negative 24y left over. Negative 24y equals 72. Divide by negative 24. Divide by negative 24. So if that negative does not come along for the ride, you're going to get the wrong number. You get the wrong number, you're going to get the wrong point. You get the wrong point, you get the wrong graph. That's why this stuff's so important. Negative 3. Okay. All right, so my y-intercept is negative 3. And remember that would look like 0, negative 3. And let's see if our graphs match up. So for the x-intercept, I'm going over to 4, positive 4 on the x-axis. For the y-intercept, I'm going down to negative 3 on the y-axis. And then all I need to do is connect those 2 points with a straight line. Woot, there it is. Okay, did you guys get the same thing? Hopefully you did. Let's ask those questions again. Would you consider this line to be going up or going down? This one's going up. Steep or gradual? Tough one. I don't know. Might be slightly gradual, I guess. It's kind of in between there. We'll talk a little bit more about that tomorrow. But that's it. Quick graphs using intercepts instead of having to use a t-chart If it's in standard form, you can just plug in 0 for x to find a y-intercept, plug in 0 for y to find an x-intercept. You got 2 points, plot 2 points, boom, you got a line. Pretty simple stuff. Make sure you practice it because you're going to need it. And there's a good chance you might actually forget this after some of the other stuff we do toward the end of the chapter. All right, good job and good luck on the assignment once you get started on it.